This is section 3.3, division of polynomials and the remainder and factor theorems. We're going to begin by dividing polynomials, and we are going to be using long division. So we have polynomials f of x and d of x, and d of x cannot be equal to 0. And the degree of d of x is less than or equal to the degree of f of x. That is because you are dividing f of x by d of x, and you can see that here. And when we take f of x and divide it by d of x, we are going to come up with another polynomial that is unique and also a remainder that is unique. And we will be placing that remainder over the divisor d of x, okay? So the degree of r of x, which is the remainder, is always going to be less than that divisor, or the remainder is the 0 polynomial, and we can have a remainder of 0. So let's talk about some of these names. We're going to begin with our polynomial's name is the dividend, and that is what you are dividing. D of x is the divisor. And q of x is the quotient. And r of x is the remainder. So we will be able to write our function in this form after we divide by d of x. Okay, so let's go ahead and talk about when we are getting ready to divide, we always want to write the terms of the dividend and divisor in descending order with placeholders for missing powers of x. So if we have a missing power, we will write 0 times that missing power, and we'll go through an example like that. Okay, so let's go ahead and begin with number 1. We have a cubic, and we're dividing it by the binomial 2x minus 5. So just like we divided a long time ago, and we will go ahead and write 2x cubed minus 11x squared plus 13x plus 15. So there is our dividend. Okay, so we're going to always focus on this, and then we're going to start with our first term, 2x cubed. And we can multiply 2x by an x squared to come up with 2x cubed. So now we'll actually multiply x squared by both of these terms of the binomial. So we have 2x cubed minus 5x squared. Okay, so now we're going to subtract. Keep that in mind. We are going to be subtracting, and make sure you use those parentheses. So we have 2x cubed minus 2x cubed, that's 0. A negative 11 plus 5x squared is going to be a negative 6x squared. And then we're going to just go ahead and bring these other two terms down. Now again, we're going to focus on this term right here and decide, and that would be a negative 3x is what we would need. So we multiply negative 3x times 2x, and we get a negative 6x squared, and then we get a plus 15x. Now again, we're going to subtract. I'll just highlight these on this problem just while we're getting used to it. And let's go ahead and subtract. So we have 13 minus 15 is a negative 2x. And then we'll bring that 15 down. Now, as you can see, we can keep going because I'm focusing on this negative 2x, and I can multiply 2x by a negative 1. So now I'll have a negative 2x plus 5. We're going to subtract that entire term, and now we'll have 15 minus 5 is 10. So now we have a remainder of 10. So how can we write what this cubic divided by this binomial is? We can write it right down here. It's equal to x squared minus 3x minus 1 plus that remainder over the divisor. Okay. So let's go ahead and try this second one. Now, as you can see, we have some missing powers here. We have an x cubed and we have an x squared missing. So that's kind of important. So let's go ahead and get this set up. Our divisor is x minus 3. And we have x to the 5th minus 3x to the 4th plus 12x minus 33. Again, we're going to be focusing on this x, and that's how we will make all our decisions of what we're going to write. So, of course, we have an x to the 4th, and that will give us an x to the 5th minus 3x to the 4th. What makes this nice is when we subtract this, we actually get a 0 there. And I actually forgot what I really wanted to show you. You don't really have to do it in long division, but I think it's important. And I should have done that just for teaching you this. Some do that and some don't with long division, but it's just important that we notice that we have those missing powers, okay? So if we drop these terms down, I have another 0, I have another 0, and I have this 12x minus 33, and that's a plus. Okay, so now we are going to multiply by a positive 12, and that will give us 12x minus 36. So we will be subtracting those, and we come up with negative 33 plus 36, and that gives us a remainder of 3. So how can we write what this is equal to? It is equal to x to the 4th plus 12 plus that remainder of 3 divided by the divisor. Again, it is optional to include these missing powers here. This is optional for long division, but I think it might be a good idea, just if you're getting comfortable and getting used to this. Okay, we have a cubic divided by a quadratic in number 3. We're going to go ahead and set everything up the same way. I don't see any missing powers, so we have our divisor of x squared minus 3x plus 4. And we have 2x cubed plus 2x squared minus 16x plus 32. Okay, and again, we're focused on that x squared, okay? So we go ahead and we'll need to multiply x squared by a 2x to arrive at 2x cubed minus 6x squared plus 8x. We'll subtract all of those, and we end up with 2 plus 6x squared, which is 8x squared. And then we have a negative 24x, and then we have a plus 32. Okay, and actually I can just leave that out there like that. Okay, so now we are going to multiply by a positive 8, and we will come up with 8x squared minus 24x plus 32. And if you'll take a look at this, look at that remainder. That remainder is 0. So what have we just found out? We've actually just found out that this cubic divided by that quadratic is exactly equal to 2x plus 8. Okay, now we're going to move on to a really special type of division. And we're going to be dividing polynomials using synthetic division. Now, synthetic division is really easy and it's really fun. However, you can only use synthetic division where your divisor is a binomial of the form x minus c, where c is a constant. So, yes, we can use synthetic division here. Look at that divisor. Let's go up here. Could we have used synthetic in number 3? No. It is not of x minus c form. How about number 2? Yes. And actually, we could have in number 1 as well if we would have divided both of those by 2, both of those terms. But that's a little bit more work, and we'll talk about that. So we can use synthetic because we have x minus c form. Now, you can read through this setup and you can read through the division, but I'm going to jump right in and teach you how to do this. But basically, we are going to be using the coefficients of the dividend to the right of the box. And we're going to put c in the box. So c goes in the box, okay? So we could do this maybe step by step with this problem, and I'll kind of follow along, but I think once you do it once, you'll be okay. So c goes in the box, so 8 is c. And it's a little two-sided box. It has a right side and a bottom side, okay? Now we're going to use all of the coefficients. We have a negative 49, a 46, a negative 13, and of course, a 1. So let's go ahead and write those. We have 1, negative 13, a positive 46, and a negative 49. And we're going to go ahead and draw a horizontal line, allowing one blank line to be left. Okay, so we've taken care of writing c in the box. We've written the coefficients. We've skipped a line, and we drew a horizontal line. And now we're going to drop the 1. You're going to always bring down that leading coefficient, okay? Drop the 1. Now let's start our division. As you can see here, we're going to multiply by the value of c. 1 times 8 is 8, and we're going to add them up. Negative 5 times 8 is a negative 40, and we're going to add them up. 6 times 8 is 48, and we add those up. We come up with a negative 1. So what does this represent? 1 represents the coefficient for x squared. Negative 5 represents the coefficient for x. 6 is our constant. And negative 1 is the remainder. So this leads us to easily saying that that division this is actually equal to, and I can move this over, that this is equal to x squared minus 5x plus 6 minus 1 over x minus 8. Okay, so that is synthetic division. So it's kind of nice. We do want to make sure that we use zeros, use a coefficient of 0 for any missing powers of x. Okay, so let's go ahead and take a look at number 4. The first thing I want you to notice is we do have a few missing powers here. I see a cube and I see a square missing. Okay, So if we go ahead and we write this out, we are going to put 3 in the box, and we will use a 1, a negative 3, a 0, a 0, 12, and a negative 33. And we'll draw our horizontal line. And I think I'm going to move this over just a touch, so I have lots of room for the other problem. And remember that first step, drop that 1. So 1 times 3 is 3, add them up. 0 times 3 is 0, add them up. 0 times 3 is 0, add them up. 0 times 3, whoops, is 0, add them up. 12 times 3 is 36. Add those together, and you'll come up with 3. So that is our remainder, okay? Now, if you notice x to the 5th, we had the 5th power, so this coefficient is going to represent x to the 4th, and so forth. And we won't write that every time, but we will write what this is equal to. This is equal to x to the 4th plus 12 plus 3 over x minus 3. See if I can fix that a little bit and make that a little bit nicer. Okay, that was a good one. Now, what do you notice here? Let's go ahead and rewrite this in descending order. So we have 3x cubed plus 25x squared minus 48x plus 20. And we're going to be dividing that by x plus 10. Now, as you can see, this time negative 10 is going in the box, okay? And our coefficients are 3, 25, negative 48, and 20. We'll go ahead and drop the 3 and go ahead and work on our synthetic notation, synthetic division. And what do you notice? This remainder is 0. So what do we have? That this is equal to? This is equal to 3x squared minus 5x plus 2, and no remainder. Okay, so what does all this mean? Well, we're going to now apply the remainder and factor theorems, okay? So if you have already used division, if a polynomial is divided by x minus c, whatever that remainder is equal to the function value at c. So it's quite interesting. Let's give it a try. So they've asked us to find f of negative 1. So we are going to put negative 1 in the box, and we are going to use synthetic notation, synthetic division. So we have a missing power at 6, 4, 3, and also an x. So we have several missing powers of x. So we have a 5 and a 0 and a negative 3. Let me move these over just a little bit. 0, a negative 3, a 0, and a 0, 2, 0, and negative 1. Okay, drop the 5, and then go ahead and perform your synthetic division. And we have a remainder of negative 1. So what does that mean? Therefore, f of -1 is -1. So it's a very, very good theorem. Let's use the remainder theorem this time to show that root 5 is a 0 of this given cubic function. Okay, so we're going to put the square root of 5. What we want to show is the 0 in the box. And we'll use our coefficients 1, -4, -5, and 20. We'll go ahead and drop that 1. So square root of 5. And then we end up with -4 plus root 5. And now when we multiply here, we get a -4 root 5 plus 5. And I'm going to have to move these two over a little bit. And then when we add that up, we'll get the opposite of 4 root 5. And then multiplying those two together, we get a -20. And guess what we get for that remainder? You guessed it, that remainder is 0. So there is no remainder. And when there is no remainder, therefore, root 5 is a 0. Okay, so when that remainder is 0, then the value of c that's in the box is a 0 of the polynomial. Now, polynomials may also be evaluated using complex numbers. So we're not just restricted to real numbers. So a complex number, a plus bi, is a 0 of the polynomial if that y value, that function value of that complex number, is equal to 0. So in number 8, we are going to show that 8i is a 0. So if 8i is a 0 of this polynomial, we are looking for a remainder of 0. Show means show the remainder is equal to 0. So let's go ahead and put our coefficients in. 2, 1, 128, and 64. And we'll drop that 2. And we have 16i. And then when we have 16i plus 1. And then we multiply that by 8i, we will have, so 8i multiplied by 1 plus 16i is equal to 8i minus 128. Actually, it's plus 128i squared, which is 8i minus 128. So let me highlight this and then let me move this over just so you have that in your notes. I guess I could write it right there. Okay, and so let's go ahead and write that in. So we would have 8i minus 128, and we'd have 8i. So 8i multiplied by 8i equals 64i squared, and that's equal to -64. So it's just nice to have those on this problem. And we come up with a remainder of 0. So if we have no remainder or a remainder of 0, therefore 8i is a 0. Okay, so let's talk about the factor theorem. So if we have f of x as our polynomial, if f of c is equal to 0, think about that. When that function value of c is equal to 0, then x minus c is a factor of f of x. And if x minus c is a factor of f of x, then f of c equals 0. Okay? So we're going to use the factor theorem to determine if x plus 4 is a factor of this cubic. So how would we do that? We're going to put negative 4 in the box. And we'll go ahead and write our coefficients. We have a 6, 11, negative 60, and negative 32. We'll go ahead and drop that 6 and go ahead and do our synthetic division. And sure enough, we have no remainder, a remainder of 0. Therefore, x plus 4 is a factor of f of x. And what else? And negative 4 is a 0 of f of x. So that's really important. Okay, let's go ahead and step this up one more notch. We are going to factor this function given that x minus 6 is known to be a factor. So let's go ahead and do synthetic division, and let's talk about this real quick. If x minus 6 is a factor, then 6 is a 0, okay? So it's really important to know that 6 is going to be a 0, so we already know we're going to have a remainder of 0. When we put 6 in the box, let's go ahead. 4, negative 24, negative 3, 18, negative 1, and 6. Drop that 4, and then go ahead and do your synthetic division. And as you can see, we expected that. We expected that remainder to be a 0. Okay? So now what do we have? We have that this function here is equal to x minus 6 multiplied by 4x to the 4th minus 3x squared minus 1. So now what we can do is we can factor that. So as you can see, if we have a 4 and a negative 3, a negative 4 and a negative 3, we can factor this into 4x squared minus 1 and an x squared minus 1. And if you need a little brushing up on your division, on your factoring, you have a times c is a negative 4, a negative 3. So we need two numbers that you multiply together to get a negative 4, and you add them together to get a negative 3. Then, of course, we divide both of those by 4x squared. And then this is equal to negative 1 over x squared, and then that's as is. So that is where we get x squared minus 1 times 4x squared plus 1. So I don't know if how you do your factoring, what method, but I don't know if you like this method or not. Okay, so now what do you notice? Now we still have a difference of squares that we can factor, and this would be in x, 4x squared minus 1, and then we'd have x plus 1 and x minus 1. And that is our factored form. Ready to go. See if I can move that down just a touch. Okay, so now let's look at number 11. We're going to write a polynomial of degree 3. So we're going to write a polynomial of degree 3 that has these zeros, has the 0, 2 of multiplicity 2, and also negative 5. So it says write a polynomial. So we can just let a equal 1 if we want. We haven't been given any more information. So we can say p of x is equal to x minus 2 all squared, since our 0 of 2 has multiplicity of 2. And then x minus a negative 5 would give us x plus 5. So we need to multiply these together. So here we'll have x squared minus 4x plus 4. And then we have this binomial x plus 5. So we'll distribute this x first. So we will have x cubed minus 4x squared plus 4x. And now we will distribute the 5. So we have plus 5x squared minus 20x plus 20. So looking at our like terms, we have x cubed, and then we have plus x squared minus 16x plus 20. Okay, so that concludes this section.